In this lesson, we will define a circle and the terms relating to them. So beginning with circle, I think most people know what a circle is. But a definition of a circle is a shape in which every point is equidistant from a fixed point within the curve. And that shape needs to be a closed curve. So we see to the right a picture of a circle where every point on the outside of the circle is the same distance to the middle as every other point. So that would be our technical definition of a circle. And then with the circle, we have the center, which is going to be point O in this picture. And then the diameter is all the way across the circle going through the center. So the diameter is the segment from R to L. So we call that segment RL. By the way, take note of the segment symbol above it. So it's a segment and not a line, because a segment comes to an end, whereas a line keeps going forever and ever. And the next term we have is a radius. A radius goes from the center to any point on the outside. So in this picture, we have two radii given. Radii is a plural for radius. One radius is from O to R, and the other one is from O to L. So the radii would be segment OL and OR. Another term we have is what we call a chord. A chord is a segment, and it's a segment that goes from any point on the circle to another point on the circle, such as this blue line. So if it's going from point S to point R, we would say that the chord is segment SR. And then we have a secant. A secant is a line, not a line segment, but a line going through 2 points on the circle. So if I were to draw a line all the way through point S and R, that would be a secant because the line keeps going forever. And the way we would name this would be line SR. And we use the line symbol above it to signify that it's a line. Next, we have what is called a tangent line. A tangent line, by definition, is a line that should keep going forever. So a line that touches the circle only at one point. So in this picture, the line touches the circle only at point L. So the tangent line we would name as line LH. And then we have what is called the point of tangency, which is the point at which the tangent line touches the circle. So in this picture, that point would be point L. Next, we have a term called a sphere, and a sphere is like a three-dimensional circle. So a technical definition is a round, solid figure, or its surface, with every point on its surface equidistant from the center. So basically a circle, but three-dimensional. So an example of a sphere would be the planets, like Mercury, Venus, Earth, Mars, etc. And I guess technically, those planets are not completely spherical, but for all intents and purposes, we can consider those as spheres. Or another example would be any round ball, whether it be a basketball, soccer ball, baseball, ping pong ball. Any sort of round ball would be an example of a sphere. Another term we have is what we call congruent circles. And we've seen the term congruent before, where the word congruent means that we have the same shape and the same size. So congruent circles, by definition, are two circles that have the same size. So here we would say circle F is congruent to circle E. And the circle symbol is just a circle with a point on the inside. And then we just use the center point to name the circle. And then don't forget the congruent sign is an equal sign with a squiggly line above it. We have also congruent spheres, which are spheres that have the same size. And when we say the same size, that would imply that the radius measure is the same. So the distance from the center to an outside point would be the radius. and the radius would be the same for congruent spheres. Next we have what are called concentric circles, and we see the prefix con, C-O-N, which means with. And then we see the next part of the word is centric, centric meaning circle. So concentric circles, by definition, are circles with the same center. And we see here that's what we have in this picture. We have multiple circles, all with the same center point. We also have concentric spheres, which are spheres that have the same center. And this one is very difficult to draw a picture of, so there is no picture to illustrate, but concentric spheres are like concentric circles, except these would be three-dimensional. Next we have the terms inscribed and circumscribed. Inscribed means inside, and circumscribed means outside. So in this picture, we can say the polygon is inscribed in a circle, meaning the polygon is inside of the circle. And then circumscribed, we can say that the circle is circumscribed about the polygon, meaning it's on the outside of the polygon. Now, to be more specific here, with inscribed and circumscribed, not only does a shape need to be inside or outside to be inscribed or circumscribed, but also the circle needs to be touching every vertex of the polygon. So we see here, this vertex is touching the circle, this vertex is on the circle, and then this vertex is on the circle as well. So if I were to have a shape like this with a circle and then maybe a shape like this, even though the triangle is inside of the circle, it's not touching every vertex. So I would not say that this is inscribed. Here's another picture where the triangle is on the outside and the circle is on the inside. And notice that the circle is touching every side of the triangle. The circle is touching here, and then touching over here, and then over here. So because it is touching every part of the triangle and is on the inside, we can say the circle is inscribed in the triangle, and we can say the triangle circumscribes the circle. And that is all the terms that we will cover today in this lesson. So that concludes our lesson. We will see you next time.